Now in this problem, let us see what actually he is asking. What we need to do here. A high strength steel bar as depicted and shown in the figure is utilized in a large construction crane. The bar possesses an initial diameter of how much? 50 milli. And you see here he gives me the diameter as 50 milli. So D naught is how much? Let me write it nicely. What went wrong with this one? D naught is equal to 50 millimeter he gives me. Okay. Due to clearance constraint, the bar's diameter must be restricted to 50.025 and D final, because it is a compressive force. So what is happening? The bar is going to bulge like this, is it not? The bar is going to bulge like this. So here this delta D he gives me how much? Delta D he gives me 0.025. Why 0.025? Because D final is how much? D final is what happened to this one? Why did this come? Okay. Why is like this? D final is, I will write D final here. D final is how much? D final is 50.025. Delta D is what? D naught minus D final, isn't it? Okay. So now I have this one. So now what else he wants me now? When subjected to an axial compression force P, determine the maximum axial compressive force. That is, he wants me to find out this value P that can be exerted on the bar. Assume that the steel exhibits a modulus of elasticity of 200 GPa. He gives me what? E is equal to 200 gigapascal. Yani I can make it 10 to the power of 3 megapascal. Okay, fine. And he also used me Poisson's ratio as how much? Poisson's ratio as, sometimes they write like this also, is equal to 0.3. Fine. This is what he has given us. Now, first of all, what we need to do, we need to write down what are the things we want. Okay. Let us just now go for the solution. Let us see what he has given. Let me just write it in the color, some green color. Okay. So now he gives me, he wants me to find out the value of P. P is equal to question mark. Okay. He gives me the value of mu. Mu is how much? Mu is equal to 0.3. This is what? This is lateral strain by longitudinal strain. Is it not? E lateral divided by E longitudinal, or you can call it as linear. Is it not? LIN I will write. That's enough. Okay. And then what else is there? It gives me the value of E. Now, what is lateral strain? Let us just write lateral strain. E lateral. Lateral yani perpendicular to the direction of applied force. Is it not? E lateral is equal to delta D divided by D or D naught. So what is the value of delta D? 0.025 divided by D naught is how much? D naught is some seen, that is 50. This gives me how much? This gives me a value of 5 into 10 to the power of minus 4. Okay. There is no unit. Why there is no unit? Because it is a ratio. I think the color is not good. Let me change the color. Okay. Now let me go up. Now E lateral is done. Okay. Now I know the formula. Mu is what? Mu is equal to E lateral divided by E linear. So what are the things you know here? E lateral you already calculated. You know this. Mu he has given, you know this. What you don't know E linear. Correct. Let us find out E linear. E linear is equal to E lateral divided by mu, that is 5 into 10 to the power of minus 4 divided by mu is how much? 0.3. This gives me how much? This gives me a value of 1.667 into 10 to the power of minus 3. Again, no unit because it is a strain, which is a ratio. Okay. Now, what are the other things we know? Now we know E is equal to what? Young's modulus. Let me again change the color. Okay. E is equal to what? Young's modulus, which is nothing but stress divided by strain. This strain is always linear strain. Remember, understand? E linear. Okay. So now therefore, E linear, I mean, you want to find out stress. Let us find out stress. Stress is equal to, because see, in this one, he has given me Young's modulus. He has given me linear. I don't know sigma. If I find out sigma, sigma is equal to force by area. So you can easily find out force. So now let me write E into E linear. That is how much? 200 into 10 cube multiplied by E linear, you already calculated. 1.667 multiplied by 10 to the power of minus 3. So see here, this is out, is it not? So now the answer is how much? You are getting a value of sigma as 333.33 megapascal. Okay. Now you have the value of what? You have the value of sigma. Once you know the value of sigma, what you can do? Sigma is equal to force. He give me the forces P divided by area. Let us calculate the area. Area is equal to what? Pi into D. Initial diameter is 50 square divided by 4. Is it not? So once you calculate the area, what is the area? Pi D square by 4 is 1963. Point, how much is that? 495 millimeter square. Don't forget to write the units. So now you know area. So you can easily find out P. P is equal to sigma multiplied by area. Sigma is 333.33. Okay. Multiplied by area is 1963.495. This gives me a value of P as how much? 4598.5 Newton. Change it to kilonewton. If you change it to kilonewton, it becomes how much? Let's change the color so that you can differentiate. I can write it as what? P can be written as 454.5 kilonewton. See, this is the value of what? This is the value of P. This is what he has asked. There is nothing special. There is no magic in this. First of all, you should not be afraid. First, you read the problem peacefully. Give a bit of time. Imagine it. Write down what are the information he has given it. That's what I did here. See, I just went up. I kept on writing what did he give. He gave me this one D naught. I write it. I write delta D, this one, this one, this one. Then I write the formulas. What he wants, I wrote. The formula I wrote. When once you do this and go slowly, you will get it. Initially, you just see the problem and you get scared. You try to memorize. Don't memorize. We are engineers. We have to use logic. We should not memorize things. Okay.